says the sun burns about 4.4 times 10 to the 6 tons of hydrogen per second. How much does it burn in 1 year? And just, I wouldn't even, let's not even worry about this, okay? So just, because we're going to do it by unit conversions. So, I was going to mark that out. We won't even let mark it out. And then the second one says the area of the Pacific Ocean is 6.0 times 10 to the 7th square miles. The area of the Atlantic Ocean is 2.96 times 10 to the 7th square miles. About how many times greater is the area of the Pacific Ocean than the Atlantic Ocean? Now, we did a problem like that. We did a problem like both of them. One had to deal with how much water is pumped over a year or falls in a year or something like that, or in a day. I can't remember what it was. And the other one was how much bigger is a planet than another planet? How many times bigger? Excuse me. This statement. Okay? Well, what happened to it? Try that again. I don't understand why I did that. That statement right there tells you what to do first. 4.4 times 10 to the 6th tons per what? Per 1 second. Now, unit conversion theory dictates that if we are going to cancel anything, then we've got to have seconds in the numerator to minutes. So 60 seconds is in what? 1 minute. So that dictates that minutes would have to be in the top, to hours, 60, 1 hour, and how many hours are in a day? And how many days are in a year?
365.
Now let's see what cancels. Seconds cancel. Minutes cancel. Hours cancel. And days cancel. And you're left with tons per what? Per year. So let's see if we can change some of the stuff. So that's 4.4 times 10 to the 6th multiplied by 3,600 multiplied by 24 multiplied by 365. Does everybody agree with that? Now I can rewrite all of those. 4.4 times 10 to the 6th. 3.6 times 10 to the 3rd. 2.4 times 10 to the 1st. 3.65 times 10 to the 2nd. What did I do there? I changed everything into what? Scientific notation. That way you got smaller numbers to work with. Unless you like whips and chains and you just like big numbers, so you have to depend on the calculator. No coughing in class. 4.4 times 3.6 times 2.4 times 3.65. What's 6 plus 3 plus 1 plus 2? 12, Hubert. Thank you, class. Glad y'all can do that simple math. Let's see. I'm going to say 4 times 4 times 2 times 4. I'm just going to do it like that because I don't have a calculator. And 4 times 4 is 16. 16 times 4 is 64. 64 times 2 is 128. So your answer is going to be probably around 128. But somebody take your calculator and tell me what it comes out to be. I'm sorry, what? 138. 138. Okay, give me the actual decimal.
1.38.
No, 138 what?
Oh, I did it in scientific notation.
Okay. Multiply these numbers for me. Those 4 numbers, what do you get? You're kidding. It should come out to be 138. 4.4, 3.6, 2.4, and 3.65. What do you get?
138.75.
0.75. Everybody get that? Times 10 to the 12th power. Now, is this in scientific notation? No, it is not. So 1.3875 times 10 to the 12 blank 2. Which way do you move this in your head to get it back the way it was? To the right. So 1.3875 times 10 to the 14th power. And that is your answer.
Where do you get 2 from? 12 plus 2.
This is not in scientific notation. So you've got to put it in scientific notation. And that's how you do that problem. So your answer is 1.3875 times 10 to the 14th power. Now, what you actually did is you took, let me erase this right quick. Let me just erase this because you've already got that written down. Whatever. I don't know why it does that, but there. I don't know how it can erase a whole.
That foreign stuff must be in that box that the words are wrote in.
Yep.
Now move it over.
There. Now, what you actually did is you took 4, 1, 2, 3, 4, 5, 6. You took 4 million and you multiplied by 3,600 and multiplied by 24 and multiplied by 365. Why do I keep showing y'all what you're doing? Am I doing it because I think you're stupid and you don't know? No. Why am I showing it to you? Why do I give you the answer and then say this is what you actually did? Why do I do that?
If I understand it.
So we see how easy that is to get the same answers before.
Exactly. If you're a person that's using your calculator, I don't know anybody in here using their calculator, so don't say, he's talking about me. If you're using your calculator and you're saying 4.46 times 3,600 times 24 times 365, you're not only missing the whole boat, you've missed the whole ocean. Okay? You're missing the whole point. Okay? My 8-year-old, I could teach my 8-year-old how to use a calculator. Okay? The whole point of me spending so much time on this is because you're going to take science in the future. Some of you may change your major. You may change to college transfer. Some of you are already figured out that you can do algebra or you can do fractions. Opens up a whole new world. You may take physics, you may take biology, you may take nursing, and you've got to deal with these guys. One of the things that we lack as a society is common what? Sense. Have you ever seen somebody at a cash register that can't do simple math? Give them 6 cents and see what happens. Some of y'all have no idea what I'm talking about. Let me show you. You ever met somebody at the cash register and the bill was $9.97 and you give them a $20 bill and then after they ring it up you give them 7 cents and watch their head explode? Alright, if you're one of those people that don't know what the change is, you depend on a calculator too much and you don't know how to think. So you need to learn that $20.07 minus 97 cents. What's $20.07 minus? What is $1.07 minus 97 cents? The dime. So you get back a change in a dime. Instead of giving me a bunch of what? Pennies. Okay? So if you're one of those people that sit there and go, well, that's what people do to me, and I don't know what, then don't raise your hand. You need to get rid of that calculator before you end up owing Walmart $200 and something because you can't make freaking what? Change. Did I do this before? Oh yeah, I love to do it. I did it at a restaurant. Some of you above Charleston go toward north of Charleston. I don't know what it is, but there's a restaurant, real good restaurant. It's an old gas station turned into a restaurant called Seaweed. The old Indians down there, I think the Indians were called Seaweed. Is that right? Y'all have no idea what I'm talking about. But anyway, there's a restaurant, and it's a great restaurant. It's about, I'd say it's probably 15 miles north of Charleston, so Mount Pleasant, north. And there was a girl there. And my bill, oh my gosh, I took 2 kids and me and my then ex-wife, the now ex-wife, and it was about $100. Okay?
Is that good?
It's real good.
Oh,
yeah.
wow.
I mean, real, authentic. I mean, there ain't no frozen food in that place at all. And we had to have refreshments. I had to have refreshments, so that's probably my bill went up a little bit. But anyway, the whole point was, I went to the cash register and the bill came up to be, I'm gonna say like $90.56.
Oh Lord.
And I gave her a $100 bill. And then I gave her 56 cents. And this is exactly what she did. She held it in her hand and she went, what is this for? And I said, may I speak to your manager?
Oh man.
And the manager come and I said, do you know that your cash register person cannot make change? Oh, I didn't know that. I said, well, I just gave her 56 cents. My bill was $90.56. I gave her $100.56, and she said, what's this for? I said, you better check that register tonight because you probably are not going to have the money you're supposed to have in it. I said, you should not be letting her run the cash register. Now, am I SOB for doing that? No, I don't think so. Why? Because that man is trying to make what?
A living.
A living. Okay?
Successful
If
business.
he sells a pound of fish, he may make $2 or $3 off that pound of fish. I mean, I don't know. I'm not in the restaurant business. But the whole point is that man is trying to make a living at that store. And if he has some incapable person running the cash register, where is his profit going? It's going in that cash register because they don't know how to make change. Think about that if you're a business person trying to make a living off of business.
Most people do this because they don't want change back.
Huh?
Most people
Yes,
do it the way you do it.
exactly.
They don't want all that change.
Exactly. And it's easy math. But you do it at a Walmart or a Target or Target or whatever you want to call it. And watch the person's head explode. Now, I shut down the McDonald's up on 81 at 85. I did it up there, and the manager had to go into his office and get a calculator.
The manager was just as bad.
Mm-hmm.
I've seen people the whole...
Now, a lot of you are
every one of them
saying,
like that.
what has scientific notation got to do with change? We have gotten away from using what? Our brain. We have gotten in the mode, and some of y'all have done this. Y'all reach for the calculator whenever we start to do a problem. I haven't even said get a calculator out, and y'all reach for a calculator. You might be one of those people if you reach for a calculator whenever you go to the bathroom. Okay? Some of y'all going, oh, let's see. Whatever. All right, the next one. So now that you feel bad about yourself. Do 25. The area of the Pacific Ocean. Now, this is the same one we did the other day, and I said, what if somebody weighs 300 pounds and you weigh 100 pounds? How much bigger are they than you? Then you take the 300 and you divide by the 100. They're 3 times bigger. Same thing here. Now, this one's easy because you don't have to do very much. Take 6.0 times 10 to the 7th and divide by 2.96 times 10 to the what? 7. Now, again, let's use our brain. The answer is going to be what? Twice as big. How did you get that? You didn't even use a calculator. 6.0 divided by 3. What's 7 minus 7? 0. 10 to the 0 is what? 1. So 2.0 times 1 is 2. 2 times as big. All right, go ahead. Somebody say, oh, well, that ain't 3. That's 2.96. Well, somebody take 6 and divide by 2.96 and tell me what you get.
But it does say about, which means
I was going, you stole my thunder. Thanks a lot. Okay? That's why you're not going to pass this class. All right. Somebody take your calculator and divide 6 divided by 2.96. What do you get?
2.02.
Oh my gosh. I'm off by 200ths. 2's your answer. Because they're said, like she said, about. They're asking for, you don't go, the Pacific Ocean is 2.02 times bigger than the Atlantic Ocean. Who in the world thinks like that? Nobody. Unless you're Rain Man. Okay? Usually you'd say, well, the Pacific Ocean is about 2 times as big as the Atlantic Ocean. That's what you say. Okay? All right, let's move on to 11.1 so I can cut y'all's homework off and give y'all a test and y'all cry and talk about grandmother dying. Fractions, we've already talked about. Decimals, I kind of stay away from because they depend on using a calculator. And percents. That's kind of what this whole section is about. Mainly percents. But the first thing I show people when we go over fractions, decimals, and percents is how to go back and forth between them, and then you can understand what percents are in terms of decimals and fractions. So, fraction, 1/2. Well, there's a fraction. How do you change it into a decimal? Well, you just do it. When you go from a fraction to a decimal, you just do what it says. I probably talked about this before. What does this say? This says 1 divided by what? 2. So you do 2 into 1. 2 will not go into 1. So you put a decimal and add a 0. 2 will go into 5 times 2 is 10. 0 remainder. So 0.5 is your answer. And of course that's elementary, and y'all remember that from wherever you learned it. But what is a percent? Well, a percent, if anybody ever watched Andy Griffith Show, and I used to give a lot of trivia questions, bonus questions about Andy Griffith, because I'm an Andy Griffith fanatic.
Me too.
But Barney talks about centus in one of the episodes. Percentus. Centus is Latin. What does centus mean?
Percent.
Nope. 100. Centus. Centipede. Century. Cent. Like 1 cent. There's 100 cents in a dollar. Centus. Centipede. Century. What else? What else starts with C-E-N-T?
Century.
I said century.
Centimeter.
Centimeter. Good. Anything having C-E-N-T in it means 100. Now what does per mean? Well, think of miles per hour. Miles over an hour. Hours divided into miles. Per means what? Divided. So whenever you see percent or percentus, that means divided by what? 100. Percent means divide by 100. So, if I give you 5%, that means 5 divided by what? 100. Which means anytime you divide by 100, you move the decimal places 2 places to the left, which is 0.05. So whenever you're given a percent, the first thing you probably will do, because you can't use 5% in a math problem. 5%, when you see this, that's kind of like 5 and a flag. All right? It's a symbol. You can't use this in a formula. You have to change it to a what? A decimal, I'm sorry. You have to change it to a decimal. Now, you can change it to a fraction, but most people don't. All right? It's kind of like if I asked you what is the factors of 54, 99% of you would say 6 times 9. Nobody's going to say, oh, 54 is 2 times 27. Nobody ever does that. All right? If you got a formula and it says percent, then you're going to change it. 99% of the time, the first thing you're going to do is change that to a decimal. This is not calculatable. Okay? You cannot calculate 5% sign. Now, there are some calculators that have a percent. And what does it do when you hit the percent sign? It changes it to a what? Decimal. Okay? So that's the difference between the three. Now, can I go from here to here? Yes. 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 So you can go between three just by manipulation and using rules, especially moving the decimal.
Where did you get the 5%?
Huh?
Where did you get the 5%?
I just pulled 5% out of there. You talking about right here?
Yeah.
Yeah, I just pulled that out of there. 10%. I was talking about right here. Fractions, I used 1/2 and I changed it to this. And then I just pulled 5% out of the air. 10% is 10 over what?
100.
And you can actually knock the zeros off like that. And you got 1 over 10, which is 1 place to the what? Left. So that's 0.1. So 10% is equal to 0.1.
So what would happen if you have 500% or something?
Okay, 500% is 500 over what?
100.
What happens to the zeros? And what are you left with? 5. So you have you increased by 5, 5-fold. You ever heard somebody say 5-fold? The Lone Ranger, that cavalry guy, say, we took care of those Indians 10-fold. That means 10 times. That means 10. That means 100% or 1,000%, basically, is what it means. Okay, 10-fold, 5-fold. Now, I don't do a lot on fractions and decimals in 11.1 because there's one thing I concentrate on, and that's this guy right here. And what we're going to do is I'm going to tell you about the 2 types of problems with percents. There's 2 types. Now, you're not going to see this in any book. This is Hubertisms. 2 types of percent problems. There's what I call the sentence problems. And then there is the Walmart equation.
Say that again?
The
Walmart equation.
Oh,
Target equation, whatever you want to
okay.
use.
Okay.
You can say Walgreens equation if you want to. All right? Because everybody's used it. It's called taxes. You ever walked into a store and you only had $10 in your bank account or your pocket? Don't say you didn't, because you'd be lying. There's always been a time when you, whether you're a 5-year-old or a teenager or a 56-year-old, walk into a store and you only have $10 in your hand. And you got to buy this, this, and this. What do you do in your head? Well, that's $3. $3, 5% interest, 5% taxes, that'd be $3.15. You've done that in your head before, right? Okay, what you're actually doing is the Walmart equation. And we'll go over that in just a minute. The sentence problems. These are on standardized tests. 5% of 26 is what number? Y'all remember these? 20 is what percent of 356? And then what percent of 16 is 5? You remember those problems from some test in your past? Those are what I call sentence problems. There's 3 of them because there's only 3 unknowns. And you do it by is, of, percent over 100. How many unknowns do we have in this equation? 3. Is an unknown. Of is an unknown. And percent is unknown. So 3 unknowns means 3 types of what? Problems. 3 types of sentences. How do you do it? Well, take your handy dandy highlighter. Let's do this first one. 5%. Take another highlighter. That goes there. And take another color. Of 26. Goes there. So what is the only thing left?
Is.
Is what? Is what number?
X.
So, let's take our handy dandy black pen and let's substitute what we got. The red is what? 5 over 100.